Right, hi guys, we're going to do 3.8 using inequalities. This is basically knowing how to do inequalities using a word problem. Got a couple of guests to share steps on how to do this and then work out some examples. So watch through these videos and you'll be ready to do 3.8.
Math and Science. In this video, I'd like to talk about how to solve inequality word problems. So let me first fill in the blank here, the steps for solving these problems, and then I'll work two examples. Okay, first what you'll do is you'll identify the numbers that you are going to use from the problems. Then you'll identify the operation needed to solve, and then you will solve the problem. And then you'll start by writing a variable, okay? And then you'll write the inverse operation of what you did, okay, to find the solution. Then you'll fill in the numbers from the original problem and the inequality symbol, okay? And so let's go ahead and work through a couple examples. And finally, your solution should not be part of the inequality. The variable is in place of the solution. So let's work these steps and solve a problem, okay? So here's our first problem, and it says Noah scored at least 12 points more than Scott scored. Scott scored 15 points. How many points did Noah score? So let's first start by identify the inequality, and our word is at least, and at least tells me that it's going to be greater than or equal to. Okay. Next, I'm going to circle the numbers. We have a 12 and we have a 15. Okay. So I next need to solve the problem. And it says that Noah scored 12 more than Scott. So I'm going to go Scott scored 15. Noah scored 12 more. So he scored 27. Okay. And so you want to know how many points did Noah score? Okay, and Noah scored at least 12 more than Scott. So there's some wiggle room there. So next, what it says is we're going to write an X first, and we're going to write the inverse operation, which is subtraction. Then we are going to write the numbers, and I'm going to write 12 first, plus the inequality sign that we came up with, and then the other number. So that is one solution, or we could write 12 minus 15 greater than or equal, put the inequality sign, and then 12. So either one of those. So those are your solutions. Let's work one more. It says, yesterday's high temperature was 80 degrees. Tomorrow's weather forecast includes a high temperature that is no more than 12 degrees. What high temperatures are forecast for tomorrow? Let's first identify the inequality. It says includes a high temperature that is no more than. And no more than is going to be less than or equal to. And next we will circle our numbers. We have 80 and 12. Now we need to find a solution. It says, let's begin. We have a high temperature of 80 and that it is no more than 12 degrees warmer. So it's going to be at least 12 degrees warmer. So I'm going to add 12 and that will give you a solution of 92. Okay. So now I need to go ahead and write this out. I'm going to start with X, put in the inverse operation, which is addition. So I'm going to use subtraction. Use the numbers. I'll write 80 first, put in the inequality sign, and then write the other number on the other side. And then, or do X inverse operation minus 12 less than or equal to 80. Okay, I hope that helps in solving inequality word problems. Just follow the steps, and Moo Math and Science uploads a new math and science video every day. Please subscribe and share.
In this video, we're going to discuss some inequalities word problems. So question number 1. Jackson's baseball team has to collect at least 160 blankets for a local shelter. Team members brought 42 blankets on Monday and 65 blankets on Wednesday. How many blankets must the team donate on Friday to meet or exceed their goal? So let's kind of decompose this here. So at least is a greater than or equal to word. You need at least 160 blankets, okay, in order to meet your goal. So we know this is going to have a greater than or equal to sign. Team members already brought in 42 blankets, so we have 42 blankets on Monday and 65 blankets on Wednesday, plus the team brings in some number of blankets, we're going to call that B, on Friday. We want this to be greater than or equal to, so at least 160. So again, 42 blankets on Monday, 65 blankets on Wednesday, and we want to know how many blankets on Friday, and that's where our variable is going to be. So to solve this inequality, I have 42 plus 65, and that gives me 107 plus B is greater than or equal to 160. I'm going to use the subtraction property of inequality, and I'm going to subtract 107 from both sides. So 160 minus 107 gives me 53, so I have B is greater than or equal to 53. So the answer to this word problem would be at least 53 blankets. Let's answer that in a complete sentence. They must bring at least 53 blankets. All right, number 2. Kyle's fencing team is selling, wow, I'm all kinds of typos today, selling calendars to raise money. They earn 40 cents on each calendar they sell. Their goal is to earn more than, there's your inequality word, more than $327. Write and solve an inequality to find the least number of calendars they can sell and still reach their goal. More than is a greater than word. You want to earn more than. Not at least, you want to have more than $327. So we know we're going to have greater than. We earn 40 cents on each calendar. So 40 cents for each calendar. Each is either a multiply or divide word depending on the context of the problem. In this case, because we're selling many calendars, it's going to be a multiplication word. So 40 cents times the number of calendars sold has got to be greater than $327. So in order to solve this, I'm going to use the division property of inequality, and I'm going to divide by 0.40. So 327 divided by 0.40 gives me C is greater than 817.5. Now I need to think about this. Is it possible to sell half a calendar? No. So I'm going to need to round this up to 318. So they must sell at, 818 calendars or more to meet their goal. They must sell 818 calendars or more. Again, you can't sell part of a calendar, and somebody would be very unhappy if they got a calendar that only went January through June and you're missing July through December. So we're not selling half a calendar, rounding up to the nearest whole number. All right, next question 3. Suppose Dev's Physics Club is going on a field trip. Members will be riding in vans that hold 7 people each, including the driver. At least 28 people will be going on the trip. What is the least number of vans needed to make the trip? Okay, so at least 28 people. Again, that's a greater than or equal to word. So we know we're going to need greater than or equal to. These vans hold 7 people each, so we're going to have 7 times V. And we know that at least 28 people are going. And we're looking for the minimum number of vans. So now I'm going to use the division property of inequality. I'm going to divide both sides by 7. And I have V is greater than or equal to 4. So they will need at least 4 vans. All right, number 4. Nathan wants to take the Metro to the Washington Capitals game this season. Nathan has 2 options. Option A, he can purchase the Smart Trip card for $10 and pay $2.15 per trip. Or option B, he could not purchase the Smart Trip card and pay $3.15 per trip. For which number of trips is the cost of option B less than the cost of option A? Okay, so let's talk about cost of option B. Since it's less than, we're going to use less than. And we're starting with option B is less than option A. So option B is $3.15 times the number of trips. And I'm going to use T for trips. Option A is a $10 flat fee to buy the card. And then we're adding to that cost $2.15 for each trip that he takes. So I'm going to solve this inequality for T by subtracting $2.15 times T from both sides. So this is going to leave me with just T is less than 10. So option B is cheaper if Nathan takes less than 10 trips. If Nathan takes less than 10 trips.
Thanks for watching those videos, and I look forward to seeing you tomorrow. Have a good one.